So, have you ever really stopped and wondered how your data gets from your screen to, well, anywhere else on the planet? It's not magic, I promise you. It's actually a brilliant set of rules that works kind of like a roadmap for every single thing you do online.
I mean, really think about it. You click a link and bam, in less than a second, you've grabbed information from a server that could be thousands of miles away. So, how does that data know where to go? How in the world does it navigate the incredibly complex web that is the internet?
Well, it turns out it follows this really specific roadmap called the TCP/IP model. So today, we're going to follow a single piece of data on its incredible journey. We'll look at every single stop, every layer, and the hardware that makes it all happen.
All right, so our journey's got to start somewhere, right? We're starting at the very bottom. Layer 1, the physical layer. This is where all that digital stuff, the ones and zeros, actually becomes physical electricity in cables. And it's home to the, let's say, simplest device in our story.
Okay, so meet the hub. A hub is a layer 1 device, which means its job is purely physical. A really good way to think about it is like a power strip, but for your network cables. Its only job is to connect a few devices together, in the same room. So, why do we call it a dumb device? Well, because it has absolutely no idea what data it's receiving. When a signal comes in one of its ports, it just shouts it out of every single other port. Seriously, imagine being in a crowded room and just yelling everything you hear, hoping the right person eventually gets the message. It's wildly inefficient, right?
Yeah, all that shouting just creates a ton of unnecessary network traffic, and it slows everything way, way down. This flooding of data just doesn't work once you have more than a couple of computers. So the big question is, how can we be more efficient? How do we add some brains to this operation?
To solve that exact problem, we've got to move up the ladder to layer 2, the data link layer. And this is where we meet a much, much smarter kind of traffic cop. And here it is, the switch. Now, it might look a lot like a hub, but trust me, its intelligence is on a whole other level. As a layer 2 device, it's designed to connect local devices with precision, not by just shouting at everyone. So, how does it pull this off? Well, every single network device, your computer, your phone, has a unique physical address burned into it. It's called a MAC address. A switch is smart enough to learn the MAC address of every device that's plugged into it, and it builds this little table, this directory. So now when data arrives, the switch just looks at the destination MAC address and forwards it only to the one correct port. See? No more shouting. I mean, the difference here is just night and day. A hub is a dumb layer 1 device that just floods traffic everywhere. A switch, on the other hand, is an intelligent layer 2 device that uses those unique MAC addresses to deliver data precisely where it needs to go. This one evolution is exactly why switches completely replaced hubs and became the absolute foundation of all our local networks. Okay, so a switch is fantastic for local traffic, communication inside your home or your office network. But here's the catch. Its little MAC address table is only useful for devices it can see directly. So what happens when your data needs to leave the neighborhood? What happens when it has to find a server on a totally different network, maybe halfway across the world? To do that, to go global, we've got to climb up to the next level, layer 3, the internet layer. And this is where we meet the true navigator of the internet. Everybody say hello to the router. Now, a router's job isn't just to connect devices. Its job is to connect entire networks to each other. It is literally the gateway from your local network out to the vast global internet. So remember how a switch uses those physical MAC addresses for local delivery? Well, a router uses logical IP addresses. And the best way to think about an IP address is like a full postal address with street name, city, state, and zip code. It tells the router not just who the data is for, but which network they're on. And then the router makes these really smart decisions about the best possible path to send that data across the internet. So let's break that down one more time. A switch manages traffic inside a single network using those physical MAC addresses. A router, on the other hand, directs traffic between different networks using logical IP addresses. Here's a great way to remember it. The switch is the local mail carrier for your neighborhood, but the router is the major postal hub that manages the entire global highway system. Now, of course, in the real world, the lines can get a little blurry. Technology is always evolving, right?
We now have these super powerful hybrid devices called Layer 3 switches that basically combine the brains of a router with the massive port count of a switch, so they can handle both local and long-distance traffic all in one box. All right, so we've talked about all the hardware that moves our data around. But what about the data itself? Let's actually rewind the clock and see what happens inside your computer before a single bit of information ever even hits the network cable.
You know, everything starts way up at layer 7, the application layer. This is where you are. In your web browser, your email, your game. This is where the actual data you want to send gets created. From there, that data gets handed down to layer 4, the transport layer, which basically acts like a shipping department, getting the package ready for its long journey.
Okay, imagine you had to mail a 10,000-page book. You wouldn't try to cram it into one giant, ridiculous box, would you? No way. You'd break it down into smaller, more manageable packages. And that is exactly what the transport layer does. A protocol called TCP, you've probably heard of it, chops your large data file into smaller pieces called segments. And, really importantly, it numbers each one so they can be put back together in the right order when they arrive.
Okay, so we have the hardware path, the hubs, switches, and routers, and we have our data all chopped up and ready to go. Now it's time to see how it all comes together in this really cool process. It's called encapsulation. This is where it gets really clever. As your data travels down through the layers, each layer adds its own little wrapper, its own header, with addressing info. This whole process is encapsulation. It's like a digital Russian doll. You start with your data, you wrap it in a TCP header, then you wrap that in an IP header, then you wrap that in a MAC header, and so on, until it's finally ready to be turned into electrical signals. And what's cool is that at each of these layers, our little bundle of data actually gets a new name. It starts as just data, then it becomes a segment, then a packet, then a frame, and finally it becomes bits, the actual electrical or light signals zipping through the cable. Each name just represents another layer of that digital Russian doll we're building. And remember, this whole thing is a two-way street. Your computer does all this work to encapsulate the data, wrapping it in all those layers. When it finally arrives at its destination, the receiving computer does the exact same thing, but in reverse. It's called de-encapsulation. It just unwraps each layer one by one until only your original data is left. So there you have it. We've followed the entire journey, from an application all the way down to the physical wire. We know the rules of the data highway, we get the difference between hubs, switches, and routers, and we've seen how data gets so carefully packaged for its trip. But it leaves us with one last question, right? When a router has multiple possible paths to send your packet, how does it decide which route is the absolute best? Well, that is a story for another time.